all 7 patients who underwent face transplantation at Brigham and Women's Hospital had bony models printed similar to this. The bone model allows us to appreciate the geometry of the bone structures in patients who have had catastrophic injuries to the face. And it's only by having this printed model that we can actually understand the complex relationships of the bone and then plan the surgeries accordingly. And so this is a standard for us to do before we proceed with a face transplant patient. And as I mentioned before, all patients have undergone this, and in RSNA 2014 we showed that there's a utility and a benefit of printing bony models in all patients. And so this is one of the key aspects of our screening process and our surgical planning, along with visualization of the bones, as well as understanding the vascular structures that are available for the anastomosis, and as well as looking at the entire skull and the face as a whole. We've undergone soft tissue printing, and this is actually a 3D printed model of Carmen Tarleton's face after her injury and when she presented to us. And you can see that there are almost very, very paper-thin tissues in the soft tissue model, and that's because Carmen had undergone this catastrophic injury and had over 60 surgeries before she came to us. And her face was basically just grafts and scar tissue. And so very, very thin amounts of tissue were available for her, and this is why she had so much deformity and, more importantly, functional deficits and enormous pain associated with that scar tissue that moved when she tried to smile or move any of the muscles in her face. One of the things that we found is that these models are highly accurate, and actually printing the 2 models together, we can take Carmen at the time she came to us and take the skull model and actually put it directly into the soft tissue model and have a very accurate representation of what Carmen was in a 3-dimensional printed model at the time before her surgery. So this was the state of her soft tissues and her bone at the time of surgical planning. And there's no other way to represent these soft tissues, and so the real usefulness in the soft tissue models, which we're really appreciating currently, is that we can actually investigate this and we can document, not just by photographs, but by a handheld model, what types of soft tissue that she had at the time of the surgery. Now, fast forwarding to today, and in recent times, we're able to use the same bone model because Carmen's lie injury did not influence at all her bones, but we're able to now soft tissue print from more recent CT scans her current face. Her current face is the allograft, the donated face from the organ donor, plus all of the remodeling and all of the processes that have occurred since she had her transplantation almost 2 years ago. And you can see now a very thick, robust face. This actually weighs over twice what the other one does, and the volume, the weight correlates to the volume of the tissue that she has. And now you can also see the accuracy by putting the bone model into her current face, and as we showed at RSNA 2014, this is a rather accurate description and a way to appreciate the soft tissues that she has today. And so we're able to see the changes over time and even keep these models and document those soft tissue changes over time. There's really no other way that we can do this, and no other way we can appreciate these 3D volumes other than 3D printing. Her point in time today is going to be different than her point in time as she continues to heal and she continues to get better in terms of her functionality of her face. Also very importantly is we're going to start studying the science of what these tissue volumes mean. And it's very likely that they correspond to other factors in terms of the face transplant science. How the soft tissues are remodeling. Is it in fact somehow the volume somehow related to rejection as they change over time? And so we have here only 2 points in time of Carmen's state before the surgery and a recent CT scan. But you can imagine in different patients we could get several points in time and start to understand the biology of what happens after face transplantation. Another interesting area for future directions is we can actually 3D print off of MR models. These were made off of CT. But if we're going to actually 3D print models and actually look at soft tissue changes, we may in fact want to use MRI because it has no radiation and it's easy to actually acquire those data on a patient like Carmen and actually look at the soft tissue changes over time with MRI or even 3D ultrasound where we can get excellent data with no radiation. So these are some of the rationales for the 3D printed model. All patients undergo bony models because we need this for surgical planning, and the science of what happens to the soft tissues is really for the first time opened up by having 3D printed models so we can hold in our hands and feel the texture and the contour and understand where the soft tissues are. So in our face transplant program, the imaging begins with wide area detector CT. We use 320 detector row CT to acquire the CT data for all of our patients. This is actually a 16 centimeter model corresponding to the field of view for our CT scans. And we're actually able to capture the key components of the face in virtually all patients that we've done using that technology. From the CT data, there's really two ways that you can analyze the images. The first is what I call 3D visualization. 3D visualization takes those CT data and reformats different planes, captures vascular anatomy, and even can assess a volume, but it does so on a two-dimensional screen. And so that 3D visualization has been used by our group and many other groups to understand the relationships between different tissues in the face for surgical planning. 3D printing is somewhat different than that in so much as it's the same CT data that we use, but that CT data then undergoes specific algorithms because the DICOM images, which is the standard method for formatting CT images, is not amenable to printing. Those DICOM images need to be transformed into another language. They're called STL files. STL stands for Standard Tessellation Language. And the way that we do that is we use two software packages from Materialize, Mimics and then 3Matics. Mimics is similar to the segmentation type of software where we actually can crop out things like the bone. And then 3Matics is actually a computer-aided design package where we can then prepare the STL files, make them watertight and then amenable to printing. At that point, we actually take the STL files and we can send them to a Stratasys printer. And these models are printed on a Stratasys PolyJet, and you can see that there's an excellent accuracy of what we expect, and we've done the comparisons between the visualization and the 3D printing so that we can fully appreciate the bony models. Now, all of our patients have used this technology to understand the 3D bony structures. One of the novel things that we've done with that Stratasys PolyJet printer technology is we've also been able to print the 3D soft tissue models. And those soft tissue models are unique in so much as they show us not just the bone, but actually a conglomerate of all of the soft tissues of the face that you can actually see that match with the bony structures. And so we can now appreciate not just one tissue type, the bone, but now we can appreciate the soft tissues around the face.